To start chapter 3, we looked at solving systems of 2 equations. Today we're going to move on to solving systems with 3 equations. Before we start here, I just want you to pause it quick and try this first problem out and see what you remember from solving. And then once you got that, then we're going to move on to 3 equations. The first one that we're going to look at after that review problem is about this Summer Olympics problem in Athens, Greece. The United States won a total of 103 medals. They won 6 more gold medals than bronze and 10 more silver medals than bronze. They want us to write a system of 3 linear equations that could be used to determine how many of each type, gold, silver, and bronze, that the U.S. won. When we're doing this, they also say let's use G to represent gold, S to represent silver, and B to represent bronze. All right, so let's start off with that first sentence. United States won a total of 103 medals. Well, if we put that information into a statement, that means the number of golds plus the number of silvers plus the number of bronze should total up to equal 103. All right, reading on. The next sentence says they won 6 more gold medals than bronze. All right, so we want to change that now into a statement. 6 more gold medals than bronze. So the number of gold medals equals the number of bronze medals plus 6. All right, finally, they won 10 more silver medals than bronze. So the number of silver medals equals the number of bronze medals plus 10. All right. Now we have a system of 3 equations. We got 3 equations with 3 variables. And this is the type of problem we're going to be looking at solving the next couple days here. Now, they didn't say to solve this, but we're going to solve it out and see what we get. One way to solve these system of 3 variable problems is to use substitution. And this one would be set up very nice for a substitution problem. The reason being, we got these 2 statements here where we could substitute and get our equation in terms of B, the bronze medals. So what we could do is take what G equals here, B plus 6, and we could substitute that in for G. We also have this equation where S equals B plus 10, so we could substitute that in for S. And we could get one statement then that is just in terms of B. So first let's substitute for G, B plus 6. Now we're going to substitute in for S. S is bronze medals plus 10, plus our 1 bronze medal equals 103 total medals. Now we could solve this and figure out how many bronze medals there were. So first let's combine like terms. It looks like there is a total of 1, 2, 3 bronze, so 3B. If we add up our numbers here, 6 plus 10 would be 16 equals 103. Now keep solving, subtract 16 from 103, and that leaves us with 87. If we divide by 3, the number of bronze medals is 29. Now, just like we've done on some of these other problems yesterday, you're not quite done when you find the first variable. Now you got to find out what do those other variables equal. So we know the number of bronzes, how many golds, how many silvers. Well, now you plug that information back in. It probably won't be good to substitute it back into the first equation, but these second 2 equations are where you're going to want to substitute. So using equation 2 here, the second one, if we use this one, that would tell us gold equals the number of bronze, which is 29, plus 6 would be 35 golds. If we go to equation 3 now and do the same thing, the number of silvers is the number of bronze, which is 29 plus 10, there'd be 39. So our final answer, we see the gold count was 35, the number of silver medals was 39, and the number of bronze we found was 29. And there's the answer. So it's one way to solve a system of 3 variables is substitution. Another method you can use, looking at problem 1a, would be to look at the three equations and see, well, does substitution work? Not quite as easy on this one. So this would be a problem we want to use elimination. Elimination is going to work better where you don't, if you don't have some nice equations to substitute in for, look at elimination. Now, here's the problem with elimination. You got to kind of take it step by step. It's not, usually you're not going to be able to wipe out and go from 3 down to 1. So our first goal here is to try to get down from 3 equations with 3 variables to 2 equations with 2 variables. So we want to look at our variables x, y, and z and see which one would be easiest to eliminate first. Our x's, our y's, or our z's. So which one here could we eliminate easiest? Well, z's have 3, 5, and 1 as their numbers. We could figure out that they go into 15, but we'd have to do a lot of multiplying there to do that. If we look at our y's, 2, 1, and 3, those numbers would go into 6. Again, there'd be a lot of multiplying. But if you look at our x's, 1, 2, and 2, we could get elimination with our x's pretty easily by just doing one multiplication. If we would multiply this top equation by -2, then we could get some elimination to happen. So what we're going to do first here is multiply everything in that top equation by -2. And we get -2x minus 4y minus 2z equals, and make sure you multiply the last number by -2 as well, -20. The second 2 equations, we're just going to leave how they are. Same with the third one. We're just going to leave it how it is because we should be able to do some elimination now. I'm going to number these equations just so you guys kind of have an idea. Let's call the first equation equation 1, second one equation 2, third one equation 3, just to help you guys understand what I'm doing as I go through the rest of the problem. Well, looking at equations 1 and 2 right now, if we just kind of forgot about equation 3 here, if we just looked at those first 2, if we did elimination on those right now, we should be able to get rid of our x's. -2 and 2x, our x's should eliminate. So the first thing we're going to do, this is going to be using equation 1 and equation 2. We're going to eliminate those. So we're going to add those 2 equations together. So if we add them up, -2x plus 2x, that would be 0, it eliminates. -4y and -1y would be -5y. If we add the next ones together, -2z and 3z, that'd be 1z, or just z, equals, and now we're going to add the last 2 numbers, -25. So what we just did was we just added equations 1 and 2. All right, our next step now, we're going to try and do some more elimination. Now, we can't do elimination with equations 2 and 3 because if we tried adding these 2 together, they're both positive. That's not going to do anything. The ones we need to add together here now is 1 and 3. We're going to add together equations 1 and equation 3. If we add these 2 together, then our x's again would eliminate. So if we add the top and bottom equation, our x's eliminate again. If we add the y's, we get -7y. If we add the z's, we get -7z. And if we add the numbers or the constant terms at the end, -20 plus 7 would be 7. Now what we've done is gone from 3 equations with 3 variables down to 2 equations with 2 variables. The rest of the problem now is very similar to kind of what we did yesterday in your worksheet. We just got to figure out now how to solve this one. 2 equations, 2 unknowns. Use elimination again now to get it down to 1. Looking at our y's and z's here, it looks like it might be easiest on this one to eliminate the z's. And we could do that by multiplying the top equation by 7. So let's multiply the top equation by 7. We get negative 35y plus 7z equals 7 times negative 25 would be negative 175. Our second equation, we're just going to leave that alone because we should see our z's cancel out now when we add this together. So adding these two equations together, we get negative 42y. Z's cancel. Adding this together, you get negative 168. Divide by negative 42, and we find out that y is going to end up equaling 4. So y is 4. Now, that's awesome. It took a while. We got one of the variables, but we're not done yet. We still need to go back now and find out what is z and what is x. When you're plugging back in, you do not yet want to go back up to the top. We had these 3 equations that we started with at the top. We don't want to go back up there yet, because if we just plug in our 4 to any of these equations, we're not going to be able to figure out x or z. We're still going to have 2 variables. So we want to substitute somewhere in these 2 equations right here, because those equations only have 2 variables. So if we substitute y into one of those, we should be able to find z. Let's pick this top equation to do it. Let's substitute y in there. So if we substitute y in for that one, we'd have negative 5y plus z equals negative 25. That's the one we're using. If we substitute in 4, we can find z. So multiplying, you get negative 20 plus z equals negative 25. Add 20 to both sides, and we find out z is going to be negative 5. So now we've gotten 2 of the 3 variables. The only one left to get is x. Here's where you want to go now back to one of the original equations and plug in order to figure out what x is. So you want to pick one of these 3 to do it. I think the top one looks easiest right here to plug in for. So let's plug in our numbers there. Remember, so far we found out that y is 4. We found out z is negative 5. So if we plug those numbers into this top one right here, this is what we get. Doing a little simplification now. 2 times 4 is 8. Let's combine these 2 like terms. 8 minus 5 is 3. Finally subtracting, x is 7. So now we found out the value of all 3. X is 7, y is 4, z is negative 5. And how you can write the answer to that then, once you've had all 3, is something called an ordered triple. Ordered pairs are where you have 2 numbers. Ordered triples are where you have all 3. So if you want to write your answer as an ordered triple, x is 7, y is 4, z is negative 5. And that would be the solution. Okay. All right. I know those are tough. I want you to try one out for tomorrow. See if you can try B and find out what the answer for this one is going to be for tomorrow. Now, start out, you want to pick out one of those 3 variables that you think you can eliminate first and then go from there. So try this one out. Do your best, and we'll check and see how you do on the next day on that one. For tomorrow, then we'll kind of pick up where we left off and go from there.